Imagine a large city. Manhattan, perhaps, or downtown Hong Kong. Iconic skyscrapers with floors stacked one on top of each other in layers 10, 20, 30, 40 stories and more tall. But why? What advantages does a skyscraper have over, say, single-level homes or low-level townhouses or condos? Well, we can have high-density packing of humans into a small amount of land. Also, efficiency. Power, internet, the mail, they're all delivered to many people simultaneously, all in a single location. So, what do skyscrapers have to do with heterogeneous integration in microelectronics? Let me explain. This is ASU. Over the past 50 years, microelectronic silicon chips, or integrated circuits, have been getting faster and cheaper at a rapid rate. This has been made possible primarily by our ability to pack more transistors into the same piece of silicon. In fact, the number of transistors in an integrated circuit has roughly doubled every 2 years, tracking a prediction made in 1965 that we call Moore's Law. Imagine that a transistor is a person from millennia ago, living in small groups, and each group is miles from the other. Imagine that the electrons that flow through these transistors and in integrated circuits are equivalent to the information humans pass between each other. Over time, human groups grow larger, till eventually we build cities, and more people pack themselves into these places. We are able to accelerate the development and transport of information since humans are now living nearer each other and working together, much like a high-density integrated circuit. There comes a point, however, when you start running out of space in a dense city. Loving thy neighbor becomes a lot harder when they are camped out in your balcony, and someone has the idea to build upward. Let's stack humans one on top of each other in apartments. What we lose in space and privacy, let's make up by lowering cost of ownership and providing additional functionalities, like a gym. This is what heterogeneous integration is all about. We take separately manufactured components and integrate them into a higher level assembly that improves performance and functionality of the system as a whole. One way to do this is indeed to stack silicon chips on top of each other, like our skyscraper, instead of spreading them apart on a printed circuit board. But there are other ways to integrate components together in microelectronics, such as building structures called silicon bridges and interposers that communicate much faster between chips. Heterogeneous integration is really a family of different concepts to enhance performance in microelectronics by optimizing how components relate to each other. Now, demands on computing are only increasing, and Moore's Law is approaching fundamental limits, where it is only getting harder and more expensive to pack transistors at even higher densities. Heterogeneous integration has a key role to play to ensure that the industry can continue to do the kinds of things that only a generation ago were not even conceivable. This is an exciting time for microelectronics packaging, much as it must have been when the first skyscraper penetrated the Manhattan skyline. Designers, materials scientists, and manufacturing engineers are all hard at work like never before to explore new ideas of building these tiny cities that lie within the devices in our pockets and at our desks. And who knows, in time, city planners may be looking at these microelectronics packages and borrowing concepts from them. This was ASU. Thanks for watching.